Okay, chapter 10, second video. In the previous video, I gave an introduction to chapter 10. So we have two populations. The first population, mean mu sub 1, standard deviation sigma sub 1. Second population, mu sub 2 for mean and sigma sub 2 for standard deviations. We take two independent random samples. The first sample from the first population, n sub 1 sample size, x bar sub 1 is the sample mean, s sub 1 is the sample standard deviation. Sample 2 from population 2, n sub 2 is the sample size, x bar sub 2 is the sample mean, and s sub 2 is the sample standard deviation. In the previous video, we looked at the case when sigma sub 1 and sigma sub 2 are known. The second section where sigma sub 1 and sigma sub 2 are unknown, which is the more practical situation. Sigma sub 1 and sigma sub 2 will rarely, if ever, be known. Okay. If the two standard deviations are unknown, then there are two cases. One is sigma sub 1 and sigma sub 2 are not equal. So if this is your first case, sigma sub 1 is not equal to sigma sub 2. So we are still interested in the parameter mu sub 1 minus mu sub 2, and the point estimate is x bar sub 1 minus x bar sub 2. The expected value of x bar sub 1 minus x bar sub 2 is still mu sub 1 minus mu sub 2. Now this was the standard deviation or standard error of x bar sub 1 x bar sub 2 if sigma sub 1 and sigma sub 2 are known. Obviously we don't know those values, so we have to estimate. So we replace wherever we have sigma sub 1, we replace it by s sub 1, sigma sub 2 we replace by s sub 2. And when we do that, then we have to come up with the degrees of freedom, and there is a formula for that degrees of freedom in page 416. It's kind of complicated formula. We don't have to worry about that because we're going to generate this information from Excel. Okay. So once we estimate the standard error in this fashion, then we can substitute this in our confidence interval formula. Of course, for us to be able to do that, we need to make sure that the sample sizes are large enough for us to be able to assume normal distribution. That is, both samples must be greater than or equal to 30. Then the confidence interval formula looks exactly same with two differences from the previous one. One is we use t distribution. Since we don't know the value of sigma sub 1 and sigma sub 2, we have to use t instead, and we use this standard error instead of that one. So this gives us the confidence interval, and a similar change should be instituted for hypothesis testing. Of course, this degrees of freedom will have to come from this formula, which is really complicated formula, but instead we're going to use data analysis, and data analysis will provide that number for us. Okay, so hypothesis testing, same three types of hypothesis, and we use the t formula. And again, it looks very similar, the only difference being in the denominator. Instead of sigma sub 1, we use s sub 1, instead of sigma sub 2, we use s sub 2. And once again, we're going to be using data analysis to generate this information, and once we have this and the p-value, then we can come up with a conclusion and interpretation for the hypothesis. We will now use the Excel data analysis command to generate all this information, including the p-value. So that's the next video.